So what I'm going to talk about today is a particular kind of challenge that I find really interesting, really exciting to try to tackle, which I'll call an operational challenge. I'm going to talk about what that is, why I find it so interesting, why I think it's valuable to tackle, and I'm going to talk about some of the sort of tactics that I found to be useful. Now, before I do that, I want to give an example of the kind of thing I'm talking about. So I'm going to talk about the life of a couch. And I want you to imagine that you leave this scintillating talk, you go home, and you go on Wayfair, and you buy a couch. Wayfair sells couches. We sell lots of things for your home, a zillion things for home. And when you do that, eventually, at some later date, shorter every day, that couch shows up at your house. So what happens in order to enable that? Well, one way it could happen is that the day that you place the order, we send that order to a supplier of ours who's holding the couch in a warehouse. They've actually usually built it maybe in Asia and shipped it over in a container. Maybe that warehouse, because it came from Asia, is sitting in a warehouse in California. You're outside of Boston, or you're in Boston. So you might think, sure, we'll send a truck to that warehouse and it'll drive to your house. Of course, we can't do that. That's too easy. What we do is, in fact, we wait until the supplier tells us it's ready. That might not happen right away. We send a truck to the supplier's warehouse. They pick it up. They take it to another warehouse in California, which we own or lease. They collect it with a bunch of other stuff until eventually we have enough things to ship across the country, at which point we send it to New Jersey, naturally, to another warehouse. And in New Jersey, we take it off. A bunch of guys take it off the truck. They put it on the floor. It stays there for a day or two. They sort it with a bunch of other things until we have enough things from all over the country to come up to Massachusetts. Then we send it on another truck to a relatively small warehouse outside of Boston, about an hour west of here. Small because it's expensive to rent warehouses near Boston. And there, it gets staged, and somebody there who's nice, unlike the people who run the carriers that go across country, calls you and says, hey, we have your couch. Are you ready for us to deliver it? And you say, sure. And then someone shows up at your house, and then nice people bring it in and set it up. That's the life of a couch. That's the happy path, right? That's the nothing goes wrong path, right? There's like an amazing variety of things that can go wrong with what I just described, right? Like the supplier cannot have the thing they told us they had. Customers love that. It's backordered. They can put something in the box. They can put the wrong couch in the box. They can put a couch with the right color in the box, but we told the wrong color on our website. That happens all the time. They can put the right couch in the box, but forget to put in the cushions. They can put the cushions in a separate box, and we don't know that there's two boxes, so we only pick up one of them. Or we pick up them both, but one of them gets sent to Georgia. Like, you know, it happens, right? The guys who are unloading it can drop it and visibly damage the box. They can drop it and invisibly damage the thing inside the box, which is actually worse. And then we might have to sort of ship you a replacement part for part of it, which is a nightmare. Replacement parts are the bane of my existence. And so, and even to the final moment, when it's going up to your house, we can mess up the delivery window. We can sort of not get there in time. Just everything can go wrong on the way there. That's part of what makes these challenges so interesting and so fun. OK, so with that kind of example in mind, I'm now going to talk about what I'll define an operational challenge as. And one of the things that's interesting about the word operations in a business context is it's so overloaded, right? Like everything gets called operations. And when I first started working in kind of larger organizations, I ran across this where there was this like, oh yeah, there's the chief operating officer. It's like, well, what does he do, right? Or she do, right? I mean, the chief executive officer is in charge. They make decisions, right? They figure out what to do. And the chief operating officer does the things? Like, what's that all about? Like, I was always kind of vague on that one. And so there's actually a couple different things that I'll pick out that all get called operations. And I'm going to say, even though they're sort of seem totally different, and maybe it's just one of those like, weird, we just use this word, I'm actually going to sort of pick out a theme about why they're similar and why they fall into this category I'm describing. So the first one I'll call supply chain operations. That's the one I've just been talking about, which is characterized by these kind of complex movements of goods, lots of things that can go wrong. Another distinctive thing, and the kind of life of a couch can kind of give this to you, is that it's actually very hard to know what's happening. It's actually not clear when you're trying to manage one of these systems what's even going on. Basic questions like, is this customer orders late? How many late orders are there right now? How many things are in this warehouse? How many things are in this warehouse that we can sell? Those questions are surprisingly hard to answer. You think, oh, that's easy. But all these things conspire to make them hard to answer. Customers cancel orders, so you don't kind of know the state of it. They cancel part of an order. Things get lost. It's very hard to know what's going on. OK, so we'll call that one the supply chain operations example. Another one is technical operations. What people in this room might think of as ops, operations, the ops in DevOps. Well, how can we understand that? Well, the Alexa talk actually was kind of useful to think about that some. One way to think about the operations team or an operations role, whether or not it's a team or being done by your internal to your group, is that you're trying to keep your services up, delivering value to your customer in the face of a kind of hostile reality, right? Like terrible things are happening. Systems are falling over, disks are filling up, large numbers of our customers are showing up in response to a promotion that no one in marketing told you about, that kind of thing. All of which kind of make your systems likely to fall over, and you're trying to keep them up in the face of that. If you have a healthy relationship with your dev team, you're trying to enable safe changes by them. If you don't, then they're also a series of sort of hostile changes to you. And just like in supply chain, it's actually the default state it's very unclear. If you're running a complex system, I think if anyone has done this, one of the most sort of strong parts of that experience is the lack of knowing what's going on. It's just like, ugh, it stopped working and we have no idea why, and eventually you kind of trace through it. There's a reason why the DevOps movement is so strongly associated with monitoring, right? Because it's giving you visibility into something that otherwise you don't know what's going on. Distributed systems which sort of keep going in partial failure modes are amazingly opaque and hard to understand because of this. Another one is sales operations. Has anyone here ever been at a company that had a really world-class, high-functioning, or just high-functioning sales team? Anyone? So I was an early employee at HubSpot as an engineer, and I saw that through a bunch of growth. And one of the most interesting parts was watching the sales and marketing teams and how good they were and how relentlessly disciplined they were. And it gave me a profound respect for what they're doing. And that's often called operations. Sales and marketing is often called operations. Everything is called operations, right? And what they're trying to do is hit consistent goals that are necessary for the growth of your business, that lead to you going public, whatever, in the face of incredible, massive things that are always changing. That was actually a really distinctive thing for me. The sales team, it wasn't like they had a thing and they just did it, and they just hired more people and those people did it. It was always having to change, because whatever was working right now stopped working tomorrow. And things that you always make these discoveries that things you thought were working turned out not to work. So getting a sense of, are we on track to hit our quotas? Are we on track to hit our quotas with the right kind of customers? Are the customers that we've acquired sticking around for long enough to actually be worth it? All those things are very unclear. And sometimes you have someone you thought was an awesome salesperson who you discover actually sold to the wrong customers, and all their customers quit after 6 months. So you're always adjusting compensation and all this other stuff. It's a really interesting kind of systems challenge. OK, so what unifies these three things? Well, I think you can hear it from the kind of theme of what I've been saying. I think the thing that's distinctive is all of them are operating in very opaque and incredibly variable environments. And that's distinctive. And that's different from normal software, right? If you have to write a piece of software, and I'll take a sort of, not quite toy, but a simple example. Let's say you're writing a blog, all right? Blogs don't exist. It's 1997 or whatever. And it can be complex, especially if you have comments and tags, and it can be quite complex. But it's not particularly, the variability isn't that strong, right? People might put in, I don't know, comments in another language. They might put in really long comments. That's not really at the same order of kind of chaos of all the other stuff I've been talking about. And it's actually not that hard to get visibility into either what features have we implemented if you're writing the software, or how many people are using it. There's some of that stuff shades into operational challenges, but to some degree, the default is it's not that hard to know what's going on with a normal software challenge. But it's very different in an operational system. And for an operational system, it's usually part of what makes them interesting is they're a combination of kind of human processes, humans doing things, and computers doing things. That's actually often why they kind of generate value, is they're able to kind of straddle those lines. And that turns out to sort of bring with it all these kind of challenges I was just talking about. So I'll offer a definition, which I've made up. So if you like it, great. But no one else said this. I think of the thing that unifies these is you're trying to create consistent outcomes in opaque and highly variable environments in the face of a kind of hostile reality. And that's part of the theme of my talk. I think of this, as I've come to enjoy these challenges, I think of that you're playing a game with an opponent, with reality. And reality is going to always win. And reality is kind of out to get you. And you're assuming not that you're operating in a sort of beneficent universe where things go according to plan, but rather with this hostile world. In the security world, I think it's not Bruce Schneier, but somebody else, is you're programming Satan's computer. Have you ever heard that one? If you're doing security, it's everything that can go wrong goes wrong in the worst possible way. Operations isn't quite that bad, but it's close. OK, so now let's talk about part two. Why are these fun? Why am I pitching this to you as a thing I think you should go and do? Greenfields are boring, right? When I was a young programmer, I think the thing I liked about programming is it was abstract and clean and not kind of messy with the real world. I could take something complicated and make this perfect structure. in my mind, and that was great. And in fact, I sort of feel like at that point, I never met an abstraction I didn't like. Does anyone look back on that with sort of shame on their early career? You're like, great, I'll add a layer of indirection. It'll be so great. And no one can later understand your system, right? So that was, for a long time, that's how I think I thought about programming. And the operations part of it, the tech operations part of it, I didn't like. I didn't really know how. I didn't really understand Unix in great detail. My friends would, and I was like, I don't really know. And the problems of keeping systems up seemed kind of messy, right? For me, that really changed when I was at HubSpot a couple years ago at this point. And over a couple years, I ran all of our Post-Mortems, which was a super interesting experience, like profound learning experience. And I kind of gradually got to this point of realizing that the problem of how to keep systems up, how to kind of make things work consistently, are actually much more interesting, much more complex than kind of pure abstract problems. And I just don't find Greenfields as interesting anymore. I find the sort of getting into the muck and the nasty real-world problems much more compelling, much more fun, and much harder. And then you have to involve human beings, and you have to get teams working together, and you have to iteratively figure it out, all these great things. One thing I tell my kids all the time, hard things are fun things, right? My kids always want to win the game right away, and I'm always trying to convince them that it's more fun if it's a struggle. These are like hard problems, and they're really that's what makes them fun as an engineer to solve. Okay, let's talk about part 3. So why do I think these things are valuable to solve? Because I think they are. I think they're super valuable. Is anyone familiar with the Mark Andreessen quote, software is eating the world? Right? It's true. I don't really like most of what Mark Andreessen says, but this one's good. And it's distinctive, just how many sort of industries have just fallen in the face of sort of the software revolution, like long established companies just getting disrupted by a more software-centric companies or organizations. Which is part of why everyone in this room is in this amazingly competitive engineering talent market in Boston, because there's this incredible hunger to take the ability to write software and turn it into value, because software is just disrupting everything, which is amazing. Software is eating the world, but ops is hard to digest. Ops is the hardest thing to turn into software. It's the last thing to go. And why is that true? Well, because to solve the kinds of problems I'm talking about, if you think about them, supply chain operations, technical operations, sales operations, you actually need a bunch of stuff. You need people who are really good at the domain, who know it really well. You need people who are really good at writing software. Those two don't always go together. You need to get those together. And you usually need a fair amount of capital, because usually you're not making the people go away fully. You're building something on top of them. And so if you put those three things together and you build something valuable, that's really hard for someone to come after you and do and follow. It's particularly hard for people to do it who are only good at writing software. And that's great, because there's a lot of people who can write software. My sort of short summary of this is that this sort of opportunity is so powerful because it's so defensible, is there is no Instagram, right? So like when Instagram a bunch of years ago was bought by Facebook for like $1 billion, right? There was like 30 guys at Instagram, 30 men and women at Instagram. And Facebook bought them partly because they were valuable, my perception was, and partly because they were a little afraid of them, right? Facebook had disrupted MySpace. MySpace was incredibly successful, and Facebook utterly destroyed them. And I think Facebook has always been a little nervous about Snapchat and Instagram. And Instagram had gotten to this incredible size with a really small team. That's partly because they didn't do the operational part, right? They were on AWS. Good for them. That's fantastic. That's not going to happen for if we build a giant network of warehouses across North America, there's not going to be a bunch of 25-year-olds who are going to in their dorm room, or college students in their dorm room who are going to disrupt us from doing that, because it requires all these things that they don't have access to. And that makes it sort of a durable, an operational advantage can be a durable competitive advantage. So some examples. Amazon, the store, right? I'm a very loyal, happy Amazon customer. No question. The core value prop for me from Amazon is the delivery experience. Because the selection is good, the browse speed is really fast, the prices are pretty good. I can actually get those things from the internet. And sometimes I want some specialist thing, maybe it's like a special kind of coffee or something, and Amazon doesn't have it. But I can find a website that has it. The prices are usually not that bad. And then you check out, and they're like, yeah, you'll get this in 7 to 10 days. And you're like, what is this, right? This is terrible, right? And it doesn't always show up, and it shows up in a bad package with crappy documentation, all this stuff. Returns are a nightmare. Amazon has made the operational challenge of delivering stuff sort of reliably. They've just nailed it, and I'm incredibly loyal as a result. And that is a nasty, hard problem, and they've kind of constantly gotten better at it. Amazon Web Services. Again, they took a really nasty problem and they figured out a way to offer you this service on top of their operations. I think I heard Jeff Bezos refer to it as the muck. They deal with the muck of actually running a data center, dealing with power, dealing with failures, all this other stuff. And when they started, they just offered you a couple things, but they've operationalized more and more, such that now you can get RDS, and you can get Redshift, and you can get all these things that they're operating for you, and that's this incredible value that they're creating as a result, right? Akamai, locally, a friend of mine who went to work there said that the thing that they did incredibly well early on is having this disciplined way to manage and operate huge numbers of servers, and that they were collecting metadata about them in this like SQL and were able to sort of get in there and understand stuff really quickly. They had this sort of operational advantage early on in what they were doing. Athena Health. A bunch of folks from Athena are at Wayfair, and one of them said the core of the company was operations. Like a huge part of what they did was revenue sort of management for doctors' offices, for lots and lots of doctors' offices, processing millions of claims with insurance companies. Can you imagine the nightmare that is, right? Like the worst day you've ever had in your life of dealing with one claim is like all they did, right? And like they got really good at it. That's like a super defensible problem to solve. I actually think Google is usefully considered in this light. In the early 2000s, when Google sort of went, in my mind, from being this like fast search engine to this kind of dominant company, they were really the first ones to figure out how to operate these sort of data center-sized computers, these distributed systems that spanned an entire data center. And some of that was sort of brilliant software innovation. They figured out MapReduce. They started using Borg and containers before everyone else did. No small part of it was they figured out how to operate those things and operate them effectively. They pioneered using cheap commodity stuff and figuring out how to make the operations of that effective. And I read somewhere at one point that they were actually more guarded about their operational secrets than they were about the things they published in research papers about the software that they had built, and which now has been picked up by everybody else. It's a little hard to remember this because it's been commodified as the public cloud by Amazon and other people. But when they first did this, it was totally revolutionary. Like the idea that you could have this service that just ran things on hundreds of thousands of computers. They were really the first ones to get that, and it gave them this real leverage to kind of get ahead and stay ahead with the things they were able to do. That's part of why for a while, like when Gmail came out, they were just way ahead of everyone. They'd give you 10 times what everyone else would give you for free because they could afford to, because they could operate it. So in general, all these things are these durable competitive advantages. All these companies, if you think about what I described, how much do you want to compete with them? Not at all, right? Like that's a land war you're getting into. If you can build these kinds of capabilities, you can create a lot of value and capture a lot of that value. Okay, so now I'm going to talk more about some sort of tactics and ideas that I've found useful in working on these things. Current supply chain job, some DevOps stuff I've done in the past, data engineering, a bunch of different places. So the first tactic is actually, I think, the kind of most foundational one, which I say is to adopt a stance of humility. What do I mean by that? I think there's a thing as a programmer which is useful, which is like a kind of confidence that you can sort of figure things out, that you're smart, that you can solve hard problems. That confidence can shade into hubris and maybe even to a sort of arrogance. You've got it, you figured it out. I think with these kinds of problems, it's actually really important to kind of invert that and assume that the problem is kind of vast and nasty, and you're not going to fully solve it up front. You can't work it all out ahead of time. You have to learn as you go. You're not going to get it right the first time. You have to sort of assume that you're sort of humble in the face of the problem, and I think that really helps you. And I've actually seen engineers who are really good and have been good at problems that didn't have this nature really just kind of fall apart in this world because they didn't want to kind of admit that they couldn't get it right the first time. They wanted to build the system, throw it out there. They wanted to build the full complex system, get it out there and go, and they didn't kind of realize how much they had to learn as they went. So I think adopting a stance of humility is really kind of key. The second one is to fetishize visibility. Like fetishize it, obsessively love it. And I cannot emphasize this enough. It sounds simple, right? Especially since I've given this framing that the core challenge is the opaqueness, the opacity of the situation. But it's amazing how much people don't do this. And I'll give a concrete example. Let's say you operate a warehouse, as one does, and you realize someone's been in the warehouse, and there's a process that's really inefficient. Maybe when people scan things off the trucks, the scan guns don't work quite the way you want, or there's whatever. And someone's developed, we have this new idea, and we've talked to the people on the floor about how to use it, and people are sprinting towards building it, and they build it, and they roll it out, and the next day, everyone's like, well, how's it working? And everyone's like, I don't really know. We can't tell, right? We don't actually have a way to measure what people are using the new flow, We don't have visibility into that. We don't actually know what the old baseline for how long it was taking to improve the thing we were talking about, and we don't know what the new one is. And we actually don't know what our target was either. Right? That sounds kind of like ridiculous. That's laughable. Who would do something like that? Everybody does that. Like everyone does that, and I'm not exaggerating. We just did this like recently. It happens all the time because what it is people conceptualize this as I see there's this problem. I've talked to the user. I've imagined a better flow. I've designed a better cut time for the trucks or whatever it is, and I just want to go build it. I don't want to waste time measuring it. And often, what you need to measure is something before you have the thing. So we know it's terrible right now. We don't need to measure it yet. We'll measure it later. This is a disaster, but it happens over and over again. So committing to building the visibility first, not as an afterthought, not as like, well, we know we really need to build this capability. Of course, we got to measure it at some point. But building the visibility first and aggressively and building it like in depth and testing it is the only way to go. And as soon as you do that, you'll discover that all the things that you're trying to build, that they don't work or things were broken. This happened with one of our systems. There was this sort of messaging between our transportation and warehousing systems, and we realized that there was problems happening there, and we started instrumenting it and sending heartbeats through and figuring out what was going on. And I described it to one of my tech leads who built this. I felt like we were in a horror movie. We were opening the door to the basement, like we were going to go down the steps, and it was just like horrible things were going to be discovered, in this world. And they were. It was really like, oh god. And that's actually like useful, is to actually think that any part of your system that you have not fully examined, that you don't have really deep insight into, is hiding unspeakable horrors, like things that will just destroy your happiness in ways you can't even describe. I met someone years ago who had done a lot of Post-Mortems at AWS. He was like, oh, blood on the walls, just like, oh, okay. That's what's going to happen when you actually turn the lights on and look in. And you'll discover things you didn't even think about that you now can get improvements and kind of fix. And so the sort of obsessively loving it, and then understanding you have to iterate on it. Because one of the things that happens is as soon as you start to get visibility, you discover that fundamental questions actually require a kind of semantic refinement. For example, how many orders are late? Right? That's a really pressing question for us. Customers don't like it when things are late. We want to know how many are late so we can manage the overall network performance. We want to manage individual late orders, right? But what's a late order? What happens if someone cancels the order, like I said earlier? What if they cancel part of the order? What if the thing that's being sent is a replacement part for an order which has mostly been delivered? What happens if you've kind of got two of the same thing and they've got one of them? And there's all these kind of weird edge cases and subtle questions you get into as soon as you start to build this visibility. So thinking about it as something you're investing in early, you're planning to iterate on, and you're kind of constantly investing in. You're never done. If people have kind of done the kind of ops DevOps world, you don't build your monitoring, you're all set, right? You're always kind of adding it, incrementing on it, adjusting it, tweaking it, figuring out how to make it better. Fetishize visibility. It's the only thing that will save you. A week or two ago, all the operations, sort of business supply chain operations, leaders of different kind of functions at Wayfair got together and spent like a full day basically walking the engineering and product management teams through all their goals for the year. And 70% of them talked about, what we really need to do is we need to get better visibility to what's actually going on so we can improve it. We need to, in order to improve our forecasting and load planning and middle mile, everybody was basically like, we need more visibility into what's going on, just over and over again. Fear data corruption. I want to say this more strongly, but I didn't have space. Live in abject terror of data corruption. What do I mean by data corruption? Well, so one of the things about data, what is data? Data is so great, big data, data lakes, whatever they are, that data makes the invisible visible. That's what it does. It takes things that you can't otherwise see and pulls them together so you get visibility into what's actually going on. So for example, data tells you, you have a big warehouse. Who knows? Has anyone moved recently? Have you had the experience where you pack all your stuff up into boxes and then that feels kind of neat and clean and you move to the new house and as soon as you start to unpack the boxes, you're like, oh God, I have no idea where anything is and now I have no space to unpack things, right? That's a warehouse, right? like warehouses have that nature. There's these piles full of boxes. Maybe you have labels on some of the boxes, but they have this sort of kind of messy nature. And so what the problem with the sort of data making the invisible visible is it tells you what's going on. You have a picture of reality that allows you to make decisions. Do we have room in this warehouse for more stuff? What in the warehouse should be put on a truck immediately because it's going to be late if we don't send it, right? What happens if that data stops reflecting reality, right? Let's imagine, at Wayfair, I'll give you a concrete example. When a truck shows up at a warehouse with a couch and a bunch of stuff on it, gets unloaded off the truck, two different systems get updated. One records the physical location of items in the warehouse. Boom, that's all it's responsible for, and that's a full-time job. There's a lot going on in there. Another one records the sort of financial kind of ownership and the kind of life cycle status of that good. You know, who's this destined for? Has it been returned or not? You know, are they waiting for it? When is it due by? What's the next warehouse it's supposed to go to? How much cost have we accrued for moving it? Kind of all that stuff, right? Those are two separate systems. That's common. Sometimes we have a problem where one of the systems gets updated and not the other. Say, maybe there's a breakdown in our SOPs on the floor. Maybe there's a tech problem. It happens, right? Maybe a truck gets sent to the wrong place, which happens. And the people on the floor, they perceive their job as receiving things. So they do this workaround that we don't even know they do. So they receive everything off the wrong truck and they put it away. And then the lifecycle systems have no idea it's there because they're like, whoa, these are all malformed requests. And the inventory management system is like, great, I've got these. And they'll sit on the wall forever, right? So what happens? Let's say you introduce a change that causes this problem. You push your bug out into production. Imagine that's just happened. What happens? Nothing. It just starts corrupting the world. You don't notice it because the data is, you have no visibility, right? Your visibility itself has become corrupted and you don't know that. There's no blinking light that's like, oh, this data is bad. It's just like, sweet, warehouse has stuff in it. Lifecycle, these orders are somewhere indeterminate, who knows? And in fact, often, you don't notice this until somebody walks around. This happened, I don't know, 6, 8 months ago, where one of our executives went to a warehouse and was like, huh, it seems like there's a lot of stuff here. It's such a bad day when that happens, because you're totally like, I don't feel like there's that much stuff there. Huh. Let me do some checksumming against other systems. Oh, shit. So like, it's just like an amazing world of hurt once you get there. And so like living in kind of terror of that, assuming it's happening all the time, building checksums and reconciliations and defense against it is kind of the only way you'll survive. And like, has anybody ever been responsible for like a database or a data system that got corrupted, and you had multiple systems that got out of sync? And you had to like dump it all to a bunch of data of directories, and then spent a really unpleasant couple days like grepping through things and sorting them and finding all the stuff and kind of knitting it back together. Does anyone know what I'm talking about? That kind of experience? Yep. Yeah. So the problem is that you can't grep a warehouse. So like when you have the problem I just described in a warehouse, like you actually get to the point where stuff is so piled up that you can't see the labels anymore, so you can't scan things, right? Things are just in these big piles, and sometimes once things get into a bad operational state, there's not enough space in the warehouse. That causes things to get worse because people stop doing the SOPs because there's not space to do them. So things get piled up. You've run out of space. You don't have anywhere to sort anything. It's like when you're unpacking your house and you've taken too many things out and you have no space to unpack your house. And then you're really screwed, right? So we ended up having this kind of situation, and we had to have a sort of creative problem solving across our ops team and our tech team and our product management team to like bulk liquidated a bunch of stuff, carved out a small amount of space on the floor, and then gradually moved stuff into that floor, kind of carefully counting all of it so we knew what was there and what wasn't, and that freed up a little more space, and then we did more return, and it took us like a week or 3 to get to the point that we got the warehouse back under control. So when things go bad in an operational system, they can get much worse before you know it. And if that happens, you often don't have great options to get out. So living in fear of your data being corrupted is the only way to go. Scale and increments. This is sort of become a kind of truism of software development, right? That you don't, like if you have a new feature for Facebook, they don't roll it out to the whole world at once. They might do a canary deploy to a small number of servers. You might say, hey, we don't do big bang deploys very often anymore, right? We roll things out in small steps, and maybe we do a launch once the whole thing's there, but we do things in increments. All the reasons why that's valuable in normal software are also true in operational systems, but it's much harder to do it. It's much more expensive in the real world to do things in increments. Let's say we are in the process right now of switching over some of our warehouses from one system to another. What's the increment to do that? Can you do a whole warehouse? That's kind of a large increment, right? What if something goes wrong and that warehouse, there's a bug or they don't follow procedures right? Suddenly, you've got these warehouses that have things coming in every day. Well, can we do a single lane coming into the warehouse? Well, then we'd have 2 processes running in one warehouse, and that's really kind of tricky. So, but we've actually made a series of investments to make this better. We actually have some guns, the RF guns that we use, that run the next generation of our software. We call them the QA guns. They hit the production data, but they run, and we have users who know that, and we work with them to test out new stuff in this kind of controlled fashion. Recently, when we were doing this, rolling out new software to our warehouses, we actually picked a warehouse that wasn't being used in the way that this software supported yet, and we were actually planning over the next 6 to 12 months to move operations to that one warehouse, and we used the move of the operations to gradually scale up. So the day that it started, it had like 10 or 15% of the traffic it would have, and a couple days later, we went up to 50, and a week later, we went up to 50 again. No, actually, we planned to go up to 50 a week later, and we waited, because the people on the ground said they had all these new people learning the processes, and they really wanted another week, and we said fine. And we waited, and that was like a non-event. because we'd planned for it that way. That was a major investment. It took a lot of work to do that. We had to plan it out. We had to organize with our carriers about where to send stuff. Totally worth it. The risk reduction was huge. One of the PMs I worked with was at Amazon, and he described something he called the innovation warehouse, which is an actual warehouse, medium-sized, not their biggest, not their smallest, actual production volume going through it. And that's where they roll out and test all their new SOPs. The couple of characteristics I thought were really interesting. The operational folks on the ground there have really good relationships with the R&D, personally know each other. The R&D folks go there, so the feedback loop to fix things is really quick because they have those relationships. The other thing is they have a first-class ability to shunt volume away from that warehouse if something goes wrong. That's awesome, right? That's what allows you to move fast, is if things start to get snarled, you can very quickly, first-class, practiced ability to move stuff away. It's very similar to the systems that we build that are technical, right? Those analogies can carry you through, but they're substantial investments, and you have to really make sure you make them in order to do stuff in a safe fashion. Next tactic, value the humans. This one's kind of subtle, but I think it's important. One of the themes that you hear a lot, if you look at the examples I was using of Amazon, Athena, Google, often people talk about it as they've automated everything, right? That's a story we hear. They've automated everything. That's so great. Well, tools and automation are clearly an incredible leverage point for kind of getting these operational systems running. But if you think about those systems as replacing humans, such that humans are an accident, you don't want humans around, you're really going to make a big mistake, and it's going to be very expensive for you. Humans are much more flexible, ultimately, than computers are. And since the whole point here is that you have this intense variability, you're always going to want humans involved to help defend against completely unexpected stuff. What you want to do is kind of get into a game where you're gradually making the humans responsible for fewer and fewer things that require kind of stupid manual labor that can get done without intelligence. But you want to keep them in your focus as people you're supporting to make strong. You want to make your operators your heroes and your partners, not the afterthought you're trying to get out of a job. And that's, again, requires a level of humility. It requires a curiosity about how they do their job. For all of these things, if it's an ops, sales ops, tech ops, supply chain ops, getting into their shoes and doing their job is amazingly valuable. We were down at a warehouse in New Jersey a couple months ago, and basically there was the guy who ran it, who's a skilled operator, hadn't worked with software folks much. I think it took him a while to understand that we were actually curious to hear about things he thought weren't working well, because people who are good at operating systems, this is actually really important to know. This was like, we did a post-mortem, and this was a key finding. The people who operate your warehouses, your data centers, right? They thrive at that because they're used to dealing with crappy systems that don't work right. And they don't bitch about that, they just work around it. That's the personality type who thrives in operations, is they kind of MacGyver something together despite the fact that the systems are unreliable. So they tend to not tell you about things your systems aren't doing well or workarounds they found out. You have to really work to build a relationship with them so they'll express that to you, because you're selecting for people who deal with crappy systems and don't complain. So you need to get them to complain. So he wasn't complaining for a while, and we're talking to him, and finally he's like, well, here's the thing. And he showed us on the labels that we printed out, we had two different barcodes, and we wanted them to scan one of them and not the other, and they were right next to each other. And the scan guns they were kind of imperfect with their targeting, so they consistently scanned the wrong one all the time. And they had to take two hands, cover one of them, and scan the other one, and they often didn't have two hands free. They also spent a lot of time looking for things by number with their eyes, and all they cared about the last 3 digits. He was like, I don't know, if you could move the barcodes apart and maybe get those last 3 digits larger, this was like a day of work, right? Like there's all these other things we wanted to do that were like months of work. That was so easy. And it drove our scan compliance, we had it improved by 10 or 20%, right, Brad? It was huge. It was an amazing win when we got it out there. But we only knew that because we were on the ground with him, built that relationship, and kind of saw that. You really have to get into that mode of valuing the humans, valuing the work that they do, and making them kind of superstars. One of the folks who was at Athena talked about they had a team of people who dealt with all these claims issues and reconciliation, and they built really powerful tools for those people to deal with all these edge cases and move things around various states. They didn't get the people out of it, they made them into kind of superstars. Make exceptions first class. So there's this idea, the MVP. Who's heard of MVPs? The minimum viable product? Who's maybe experienced the MVP as an excuse to build a crappy version? Okay, right. So one of the things, I described the life of a couch, and I described everything goes right, the happy path. One of the things that I ended up saying, I think I was having a really bad day. Like I was in one meeting after having been in like 4 hours of like troubleshooting this disaster that was happening, and there was like a new project getting spun up, and somebody was like, oh yeah, for the first version, for the MVP, we're just going to build the happy path. And I basically lost my mind. I was like in the meeting, it was like a bunch of people I didn't actually know very well, and I was like, the happy path is not an MVP. Right? Like the happy path, you have to have a plan for exceptions. You don't have to have like a bulletproof system, but you can't just be like, we're going to ship stuff to people, and if it doesn't work, then I don't know, we'll figure it out later, right? You have to have some plan, or the exceptions will just destroy you. And again, this doesn't mean you have to gold-plate it on day one. The plan can be, we track it in a spreadsheet, and there's a guy who looks at the spreadsheet. That's a great plan. The plan can't be, exceptions won't happen. Right? Because not only will they happen, but they will tend to then kind of blow up and consume your time and or make your customers unhappy in ways you were kind of not expecting. And the final one I'll throw out is to, I feel like, run great postmortems. One of the best ways to learn from reality is to observe your failures. What went wrong? It's really, I think, the sort of ability to learn from things that didn't work out is necessary to build these operational systems. It's sort of a key capability. So getting really good at running postmortems, consciously investing in getting better at them, practicing that, working on what fixes actually came out of it is the sort of feedback loop that you need in order to learn from reality. OK, so now I'll sort of sum up. If you can put all this together and you can take something that's operational and turn it into a reliable service, it's amazingly valuable. It's valuable to your business. You can build things on top of that. A bunch of the companies that I picked out in my examples have built platforms on top of that. By offering their operational capabilities to others, they're able to create value and capture a lot of it. You know, Wayfair, part of what we're doing is we're setting up this proprietary logistics network, and we're getting good enough at it that our suppliers will rent space in our warehouse because we can fulfill so much more quickly, and they get a sales lift as a result. We're creating value for the customers because they can get goods faster, and we're sharing that value with our suppliers, and we're capturing some of it for ourselves. That's the kind of thing you can do if you sort of master these operational challenges. You can also offer things to customers that they didn't know they could want. That was my experience of Prime when it first came out. I didn't know I could want things in 2 days. That's what we want to do with furniture. We want to say, I didn't know I could get it in a week, and I could get it for free delivered into my house by someone really nice, and that it could just work. Like, we want that same surprise. To get there, you have to kind of get through this kind of operational march. OK. And the final thing is, I think my recruiting team will actually assault me if I don't say this. Wow, do you know anyone who has these interesting operational challenges? This is what we're doing. Wayfair has like a lot of engineers. Broadly, we fall into the storefront engineering team. They build stuff facing customers and the website, and operational engineering, which is all these kinds of problems. Fulfillment, finance, order management, all that stuff, kind of nasty, hard, real-world problems, and it's super fun. So basically, if you're interested in talking more about this kind of thing, either at Wayfair or just in general, I find these things super fascinating to talk about. I encourage you to come by and chat, or to reach out to me at dmilstein@wayfair.com. So that's my talk for today. Questions? Should we do questions? I guess. Questions? Mike, should I do questions? Does anyone have any questions about any of that? Yes?
So just a quick question. I really enjoyed the presentation.
Thank you.
It went right to home.
You like the presentation?
My question to you is, did you get any resistance from leadership in wanting to implement some of these tactics, like healthy postmortems, for visibility?
Yep.
What were some of the tactics you used to get
Sure.
buy-in at the senior?
OK, so so I think the question was, if I look at these tactics, healthy postmortems, building invisibility, did I get pushback from leadership? How did I get buy-in, especially, let's say, from the business side, from business operations? That's actually an interesting question. Wayfair's business operations is super strong. They're also super oriented towards speed, but there's this tremendous urgency, to go as fast as possible. So I think when I joined, a bunch of things had been going wrong. And so part of what the narrative was, to make them go better, we all knew we needed better visibility. That wasn't a hard sell, if that makes sense. I've had a lot of luck with framing those things in terms of the pursuit of speed. So if I say to everyone, whoa, I'm actually even imagining saying this. I'm like, I'd get fired immediately. If I said to the COO or to Neeraj, the CEO, guys, we really need to slow down rolling out these warehouses because it's really going, it's kind of chaos. Like, I would not get out of the room alive. Like, that would be a disaster. But they've actually said, James has said, who's the COO, has said to me, hey, if we're going to go faster to our sixth warehouse by being more careful with the first one, I want you to tell me that, right? So like sort of embedding it in a narrative of true speed, we can get out really fast with one of them, but then we're going to just get destroyed by trying to support it. We need to how much, and one of the framings that I've given for visibility, which is actually very successful, is we want enough visibility to know how fast we can go to be right on the edge of safety. And we need visibility to do that. And this warehouse launch that we're in the middle of, which is, we had a couple really rough ones. This one's been going really well. It's because there's this really good metrics and visibility, and everyone, I think, is very aligned about like how well that's worked. Anyone else? Questions? Cool. Thank you.